So once again, we're jumping around a little bit, but I want to make sure this gets done. Graphing linear equations. What's the word linear mean? Line. How do you know it means line? All they did is they took the word line and turned it into an adjective to explain how the equations will end up. And to be an equation, there must be an equal sign. So we are going to graph them, which means basically if you look at this title, we'll be looking at the equation of lines, and we will graph them. All right, so that's pretty intense. So standard form, does anybody believe they know standard form? Maybe from Algebra 1 or Algebra 2 or various other classes. Standard form. AX plus BY equals C. Basically, all that means is the X and the Y are on the left side, just kind of hanging out, and then the other numbers on the right side. A, B, and C are just being representing numbers here, and they can pretty much be anything, except for some reason. I know why, but the books and mathematicians throughout the years have given certain rules about A. They have given, and I know why, but they really don't need to have these rules because you're all very smart. They're trying to avoid you from making mistakes, but I think it makes it harder. But anyways, we'll follow the rules in case you go on and you do this right. So A, remember that's a number, can't be negative or fraction. And somebody said 0. That's a really good answer. Not what I was looking for, but because it can actually be 0, but that's a good idea. So it can't be negative or a fraction. And then of course people say, well, can we put a decimal in there? I said, well, the decimal is kind of the same thing as a fraction, so let's not do that either. All right. Now again, those are the rules that have been set forth by mathematicians all along the way. Does it really change the graph if that's a fraction or not? No, it's the same equation. It just looks different. Okay. So we'll follow those rules. If you want to get to a point where you don't necessarily have to follow those rules, take some more advanced classes, and I'll tell you don't have to. So that's really the only one that has some little rules next to it. Slope-intercept form. That's a big one. That's a nice one. It's really easy to graph when it's in that form. No, you're doing point-slope form. Yep, we're going to be getting to that soon. Y equals mx plus b. Why? Who came up with the name slope-intercept form? I really don't know, but I know why they came up with it. Because that equation very easily gives you the slope, which we talked about earlier this year, and it gives you the y-intercept, meaning where it hits the y-axis. The slope is simply right there, whatever that number is, m, is the slope. And this one right here is the y-intercept. So they were very clever and kind of put slope and intercept together to give it its name, to kind of tell you what it would very easily give you what kind of information. And if you stick with me long enough, I'll give you some nice little shortcuts from standard form too. Yeah. Slope, well, we're talking about slope a lot here. We probably should review what slope is. Does anybody remember what? No, that's Pythagorean theorem. Well, slope is always stood for by m. What's that little triangle thing again? Change, or it's a Greek letter. Yep, it does start with a D because it does look like a D. Delta, very good. It is the capital version of delta because you will get the lowercase version of delta if you take calculus. It is delta y over delta x. And it is so hard for people to remember that. You know why? Because when you graph, which one are you used to graphing first? The x value. And which one comes first here? The y value. You see how that could be confusing? I understand that. I see why you could get confused. But remember here, it is the change in y over the change in x. Some people are good enough just seeing that, but some people like the formula. That's fine. You've seen that formula before. Use it. It doesn't bother me any. Y2, and remember, that's just subscript, those little 2's and 1's. It's not a square or anything like that. So those are some forms that you're going to hear me talk about. I'll say, okay, standard form, slope-intercept form, slope. I'll be using those words. And if you ever forget what they are, just refer back to here. Any questions so far? Well, let's try one. Right now, I can tell you that right there is a linear equation. I can tell because of the exponents that are on x and y. What is the exponent on x right now? There's a little 1 up there, correct? And I'm adding y to the first. If it's x to the first and a y to the first and they are separated, guess what? Yeah, it's going to be a line. And what we're going to do here is one of the methods that you can graph with. Well, of our forms, is this in one of them? This is in standard form, isn't it? When it's ever in standard form, one easy way to graph is called the x-intercept and y-intercept method. Okay? What it really boils down to is x-intercept is wherever it hits the x-axis, which is this one right here, correct? Can you tell me anything that well, that was pretty good. Anything that every point on there has in common? No matter what point you pick, they all have something in common. Okay, they're all on the same line. How about if you looked at their ordered pair? The y value is always, wait a minute, it's on the x-axis and the y value is always 0. You see how that could get, ooh, what's going on there? And how about the y-axis? What can you tell me about every single point on the y-axis? Which part of the ordered pair is always the same? You see how they always flip-flop? X-axis, y has to be 0. X-axis, y has to be 0. Y-axis, x has to be 0. Got it? So here's what I do. You're all used to these, right? To find the intercepts, I go like this. And I fill it in. That will give me the x-intercept and the y-intercept guaranteed. Okay, that means right here I'm going to put 0 in for x. And I'm going to find out what y value will make that equation true. So if I'm putting 0 in for x, it's 3 times 0 plus 4y equals 36,000. It's a plus. Well, what is 3 times 0? Okay, so that term basically is gone, right? Well, how many variables do we have left now? 1. Can we solve for that? That's pretty easy to solve for. How do you solve for y in that problem? Just divide by. So the y value then is 9,000. So in other words, 0, 9,000 is actually an ordered pair, two numbers grouped together that makes that equation true. So if I put 0 in for x and 9,000 in for y, it makes it true? Yep, it does. So now, do I do the same thing, just take this 0 and put it in the same place? No, this 0 I'm putting in for y. So that 0 I put in there. So is the 3x now kind of back into the play here? Yeah, so it's 3x plus 4 times 0 equals 36,000. Again, this is called the x and y intercept method of graphing it. Well, doesn't something very similar happen this way? Now this term, on, and divide by 3. So x is 12,000. So where does 12,000 go in my little table over here? Yeah, the only one missing, right? So in other words, I have 2 points that are supposed to make that equation true. Are there only 2 points in the entire world that make that equation true? Well, there's a lot of them, right? And that's what that line that we're going to make represents. It represents all the answers that make it true. And one of the ordered pairs is 0, 9,000, for those of you that like to see them this way. And the other one is 12,000, 0. How am I supposed to grab 0, 9,000 when it only goes to 10? Just keep making tick marks until you get there? Or why don't we make each tick mark, instead of making it 1, let's make it 1,000. All right? So if each tick mark is 1,000, now 0, 9,000, is that up here where I made the dot or to the right where I made the dot? Which one? The first one or the second one that I made? The first one was up here, the second one's there. Which one's 0, 9,000? The first one. X value is 0 up there, right? So that's good. Now this one is a little off. I was going to change the graph for you, but I decided that might confuse some of you if I started moving the x and y axis all over the place. Because you agree, if I'm going to graph 12,000, 0, this is 1, 2, 3, 4, it only gets to 10. So just go ahead, make a couple more. Goes like that. So those 2 points are guaranteed to make that equation true. But you already told me there's more. There's more little groupings of numbers that make that true, and they are all on that line. So how many answers does that equation have? Infinite. So you're telling me if I figured out what that ordered pair was right there, it's kind of in the middle of nowhere, but if I figured out that x and y value, it would make that equation true? What if I picked this ordered pair down over here? No. What if I picked the one that's way up there? Yeah, that's going to make it true. Okay, and that's the whole idea. I think a lot of you have graphed these lines before. Oh man, I hate graphing lines. Why do we do this? Well, you're showing where all the answers are. Because do you want to write all the answers to this? No, because you'd never be done. So you're showing, and that's why you have the line filled in, because those answers actually work. Remember, sometimes you did some dashed and all that other stuff. That's because those actually weren't answers to the question. Well, that line right there answers that question perfectly. Okay, is that the only way you could have graphed it? No. Are some of you probably going to go to an XY table every time and just kind of put in values? Yeah. Do I have a problem with that? Not really. Okay. But then you're going to have to tell me that's what you did. Okay. So any questions on this? Is again really good when it's in standard form. Just use X and Y intercept and go. And all you have to do is set up what I did here. Put 0 there, and you're good. Okay. Questions? Well, let's see what we got next. Yeah, we can do this. Parallel lines. Have we talked about that before? Have we talked about parallel lines? Yeah. And off we go. That's getting really annoying, but parallel lines. What do you got? Yeah. Two lines that will never ever touch on the same plane. Is that pretty good? Yeah. The part that he said on the same plane is actually pretty important, because if you get off of being on the plane, you get into a completely different branch of geometry. So that's probably pretty good. Lines in the same plane that do not intersect. Boy, that's pretty much what just got said. So if you like that other definition, go right ahead and write that one down. But I think we know what parallel lines are. What's that symbol they use when they want to use parallel? What do they do? Just, yeah, two lines. And keep in mind, they do make the two lines this way for the symbol of parallel, because if they made them the other way, it would look like an equal sign. All right. And one thing that is very important, we've been talking about slope today. If you have parallel lines and they're never going to hit each other, the slope will be the same. Okay. What'd you come up with for perpendicular lines? Any ideas there? Yeah. Beautiful. Two lines, and let's see what I have. Well, that's, I think, almost word for word what I have written there. Two lines that will intersect to form a right angle, and it says the slopes will be opposite reciprocals. Doesn't look like I spelled that right, but once I look again, I did. For some reason, it looks wrong. So, okay, they form right angles, so that's 90 degrees, right? Yeah, okay. Slopes are opposite reciprocals. We probably better talk about that. But I'm guessing we're getting pretty close.